So what's a margin of error? Well, what a margin of error is, here, let me get a board going here. So I guess we got to look at the calculation and then that'll help you make sense of what it's actually helping us find here. Let's see here. I want to draw. So if we remember the formula for the margin of error, it's the sample mean plus or minus for the z distribution. Remember, we're going to use the z distribution if we know the population standard deviation, right? Divided by the square root of the sample size. And if we're dealing with proportions, it's the same margin of error, except now we're dealing with a p hat, how many successes out of the total times however many standard deviations. That critical value of z is what helps us do that. Tells us how many standard deviations. Wrong formula for that. Isn't that the p hat times 1 minus p hat times q, which is 1 minus p hat over n, and then we take the square root of that mess. And then, of course, if we don't know the population standard deviation, and we don't know, if we don't know the population standard deviation, we got to use the t distribution. So that's some critical value of t with n minus 1 degrees of freedom, right? Whatever that means. But I've got a video for that if you want to see it, but we don't know the population standard deviation, so we should be using S for sure. S over the square root of n. It doesn't matter what type of distribution we have. The margin of error is always how many, see that this is the z-score that cuts off, or t-score that cuts off the middle whatever percentage. So I'm going to use that data. I could go use the table. It's a little more awkward to use. This works pretty well. We want to know a value from an area because we know the probability. If I'm looking for a 95% confidence interval, I'm going to do 0.95, and I'm going to go between, because I want to know, see, now that's 95% of the distributions in between those two cutoffs, whatever they are, and the z-score from negative 1.96 to positive 1.96 cuts that off. So that's what we go in here. We'd write here. Let me get a pointer. That's what we'd replace the z star with. It would be 1.96. Then we add it and subtract it. That's why it's plus or minus. Okay. What if they want us to find a 90% confidence interval? Well, we go 0.9 and calculate it. It's only 1.645. That's because if you look at the table, it's in between a couple of values, that's why the calculator is much easier. Okay. And what if I want to do an 82% confidence interval? My math asks some of those kind of weird questions. Type in the area is 82 and see it's in between. Actually, it's less than the 1.645, isn't it? Because we got a lower level of confidence. We are only catching not 82% of all the possible sample means. Okay, so that's what the critical value of z is, and then you just multiply that by the standard deviation, and that tells you the upper and the lower. Now, the limit. So I'm going to make another plug for the David Lane, the Rossmann Chance compute calculator. Let me try to move this stuff out of the way. Rossmann Chance. The nice thing about this Rossmann Chance, where is it? Theory-based inference. This will do, it'll do proportions. It doesn't do the z distribution. So it doesn't do the x bar plus or minus z star where we know the population standard deviation. But it does deal with proportions. It also deals with the t distribution. So when you don't know the population standard deviation, you got to use the t distribution, as long as, what is it? If the parent population is normal or if you have a sample size bigger than 30. And notice they aren't even asking you for that sigma number. They're asking you for the S. So that's another flag that tells you it's a t distribution. And so I don't know, I'm gonna make something up here. We got 35 people. Their average time that they slept last night was 6.4 3 hours, and the standard deviation is 0.25. I'm making this all up. Calculate it, and we're going to do a confidence interval, and we're going to put in our level of confidence. What if we do a 90% confidence interval? Okay, there's the range. That's the X bar minus the margin of error, right? That's X bar minus this number, and it's X bar plus this number, and we don't know what the number is. However, something I'm going to ask you on the next quiz and on the final exam, and there's some questions like this in WebAssign. There's also a question like this in the textbook. What I'm going to ask you is, what is the margin of error? Write this, right here's a confidence interval. It's a 90% confidence interval. What's the margin of error? What's the sample mean? Of course, we know the sample mean is 6.3, right? You know it's 6.3, but what if you didn't know any of that? So we know that this is going to be X bar plus or minus some margin of error. And what they're asking us to do is to either write it in this form or to figure out what the sample mean is, the point estimate, what the margin of error is. So what we do to find the sample mean, we know this is 2 margin of errors wide because it's plus or minus. We subtracted the margin of error and we added the margin of error. So that makes it's 2 margin of errors wide. So if we find the sample mean, we're going to do the point estimate. We use the upper bound minus the lower bound. Hit equals on your calculator. Don't just hit divide. Got to follow order of our operations. And then you divide that by 2 because there's 2 margin of errors. Once you know the sample mean, you could just subtract one of these from it, and they'll tell you the margin of error is. But the other way to do it, if you're looking for the margin of error, you can do, oh, sorry, this should be addition. This should be addition. I'm trying to find, don't believe I did that. We're going to add the 2 and add the 2 numbers, divide by 2. That'll tell me the sample. So I'm going to restate this because I messed you up. To find the middle, we have to add the 2 numbers, divide by 2. If I want to find the margin of error, that's when we subtract them, right? We're going to do 6.3715 minus that the lower number, 6.2285. Then divide that by 2 because that's the width, right? That's from down here to up here, and we want to find well, this is not really this is the standard deviation. This is something a little different, but it's the same kind of thinking. We want to find what the margin of error is, which is the same here as it is here. So we'll just divide that by 2 because it's 2 margin of errors wide, right? Okay, so to find if they give you the confidence interval in this interval form, right? This parentheses form looks like a point. You add the 2 numbers, divide by 2 for the mean. You subtract them, divide by 2 for the margin of error, right? And then, I mean, we could find the standard deviation, but I'll never ask you that. And you'd never want to do that. Okay. All righty. Yeah, that's the reason why I'm having you do that. That just gets you some more understanding about what the heck's going on here as far as margin of error and the point estimate. Okay? And like I said, you don't have to use the formulas if you don't want to. My suggestion, do it for the z-score ones where you know the population standard deviations. That's pretty easy. And for everything else, just use the calculator. You'll see next week we'll start doing significance tests in chapter 8, and then chapter 9 we do 2. We're comparing 2 different populations to see if they're statistically different. And the formulas are horrendous. I'd highly recommend you use this or some other kind of calculator, but I like this one. This usually works. Okay, I hope I answered the question, what is a margin of error? See, the margin of error captures that percent in the middle of all the possible p-hats or x bars, or we could even do variances if we want to. They do confidence intervals and significance tests about variances sometimes. So we're only going to worry about means and proportions. Okay, so give me a yell if you need some help and if you need more than this. And